The discovery of a black hole triple system, a groundbreaking development in astrophysics. The universe is vast, filled with mysteries that continue to challenge our understanding of the cosmos. Despite rapid advancements in space exploration and the development of powerful telescopes, much of the universe remains out of reach. One of the most fascinating and mysterious phenomena discovered so far is the black hole, an object with such intense gravity that not even light can escape its grasp. While black holes were once theoretical constructs, they have become crucial to our understanding of gravity, space, and time. Recent findings, however, have changed everything. Astronomers have detected the first-ever black hole triple system. This discovery is still in the early stages of research but has already raised questions and presented new challenges to our understanding of these strange objects and their role in the universe. What is a black hole triple system? Before exploring why this discovery is so important, it's essential to first understand what a black hole triple system is. Historically, black holes have been observed in binary systems, where two black holes orbit each other due to their mutual gravitational attraction. These binary systems have been crucial for studying black hole mergers, the nature of gravitational waves, and even the formation of supermassive black holes that are thought to reside at the centers of galaxies. The discovery of a black hole triple system, however, introduces a far more complex scenario. A triple system consists of three black holes that orbit one another. This configuration is vastly more complicated than a simple binary system, as the three black holes exert gravitational forces on each other, causing their orbits to shift and interact in unpredictable ways. These chaotic interactions could lead to more frequent black hole mergers, which would, in turn, produce gravitational waves, ripples in spacetime that could provide valuable data on the fundamental properties of black holes. A look back, the history of black hole discoveries. To fully appreciate the significance of this new discovery, it's important to take a brief look at the history of black hole research. The idea of a black hole dates back to the late 18th century when the British scientist John Michell first proposed the concept of a dark star. This was an object whose gravitational pull was so strong that light could not escape from it. While the idea was purely theoretical at the time, it set the stage for future discoveries in astrophysics. In the 20th century, Albert Einstein's theory of general relativity provided a more thorough understanding of gravity and the curvature of spacetime. According to Einstein's equations, if a star were massive enough, it could collapse under its own gravity, forming a singularity, a point of infinite density, and creating what we now recognize as a black hole. For much of the 20th century, black holes remained theoretical. However, advances in observational technology, such as radio telescopes, helped scientists infer their presence. In the 1970s, astronomers observed X-ray emissions from binary star systems in which one of the objects was invisible but exerted a strong gravitational force, indicating the existence of black holes. These findings helped confirm the existence of stellar mass black holes, which typically have masses several times that of the Sun. In the 21st century, the detection of gravitational waves revolutionized black hole research. These ripples in spacetime, caused by the acceleration of massive objects like merging black holes, were first observed in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. This discovery marked the first direct detection of gravitational waves, opening a new window into the study of black holes. Why is the discovery of a black hole triple system so important? The discovery of a black hole triple system is significant for several reasons. First, it presents a new and previously unobserved kind of interaction between black holes. In a binary system, two black holes orbit each other in relatively stable orbits, influenced by their mutual gravitational pull. However, in a triple system, the gravitational forces between the three objects become much more complex, leading to highly dynamic and chaotic interactions. This new discovery could have far-reaching implications for our understanding of galaxy formation and evolution. Many galaxies, including our own, are thought to contain supermassive black holes at their centers, which influence the motion of stars, gas, and dust. By studying how multiple black holes interact in a system, scientists may gain new insights into how galaxies evolve over time and how black holes shape their surrounding environments. Additionally, the detection of gravitational waves from a black hole triple system could provide a wealth of new information about the properties of these cosmic giants. Gravitational waves carry data about the mass, spin, and other characteristics of the black holes involved. By studying the waves produced by such systems, scientists could learn more about the physics of black holes and potentially test fundamental theories of gravity in extreme conditions. Gravitational waves. A key tool for black hole research. Gravitational waves are playing an increasingly important role in black hole research. These waves are caused by the acceleration of massive objects, such as black holes merging or interacting. The ability to detect and analyze these waves has opened a new avenue for studying the universe, allowing scientists to observe cosmic events that would otherwise remain invisible to traditional telescopes. When two black holes merge, they produce gravitational waves that propagate through space. These waves contain valuable information about the black holes involved, including their mass, spin, and orbital characteristics. By examining the shape, frequency, and amplitude of these waves, researchers can gain deeper insights into the properties of black holes and the physics of the universe. The discovery of a black hole triple system offers a unique opportunity to study gravitational waves from a more complex system. Instead of focusing on the merger of two black holes, scientists now have the chance to observe how three black holes interact with each other, producing gravitational waves that carry new information about the behavior of multi-body systems. How do black hole triples form? The formation of black hole triple systems is a subject of great interest among astrophysicists. Understanding how these systems come into being could provide new insights into the evolution of galaxies, the dynamics of star clusters, and the processes that lead to black hole formation. One theory suggests that black hole triples could form in dense stellar environments, such as star clusters. In these environments, stars and black holes can interact gravitationally, leading to the creation of binary systems. Over time, these binary systems may merge with other objects, eventually forming a triple system. Another possibility is that black hole triples arise from the merger of two binary black hole systems. The gravitational influence of one system could cause the other binary system to become bound to it, resulting in a three-body system. This process could unfold over millions or even billions of years, as the black holes interact and adjust their orbits. The future of black hole research. The discovery of a black hole triple system is just the beginning of an exciting new phase in black hole research. As scientists continue to gather data from this system and others like it, they will uncover more details about how multiple black holes interact in complex systems. With the development of next-generation telescopes and further advancements in gravitational wave astronomy, the future of black hole research looks promising. Researchers are particularly eager to observe more black hole mergers, not only from binary systems but also from more complex configurations like the black hole triple system. Each new discovery brings us closer to answering some of the most profound questions about the universe, such as the nature of dark matter, the origins of galaxies, and the potential for life beyond Earth. Studying black holes is not just about understanding these enigmatic objects. It's about exploring the very forces that govern the universe. By examining how black holes form, evolve, and interact with their surroundings, scientists hope to unlock the mysteries of the cosmos.